Hi, Kanwal.
Oh, hi, Christine. You look like you mean business.
I do. Framing business, in fact.
A framing business?
Yeah. Actually, I brought in these materials for the show today. You know, I'm doing some framing on the side, and I have to frame some pictures for the Math Easy Place Photo Club. So in order to do that, I have to calculate how much frame I'll actually need.
Oh, that's great. That's perfect for today's show.
Right, which is about algebraic expressions, solving problems and equations, inequalities, and absolute values. Hi, and welcome to Math Shop, where no number is too big or too small for us to crunch. You know, some people steer away from algebra because of the letters. Maybe they don't think letters belong in math, but in fact, algebra is useful because we can often use it to represent real-life problems. My framing job is a good example.
So what are you going to frame first?
First up is the winner of this year's Math Easy Club Focal Point Award, Mellow Morning.
Oh, that's nice.
Yeah. And I picked out this framing material to match the color. Now, Kanwal, suppose I don't know how big the picture is or how much framing material I'll need. First, we'll have to measure. Euclid? Okay. So it says that it's 30 centimeters wide and 50 centimeters long.
Yes, and to find the distance around the picture, Euclid has added up the four sides and written it out as an equation.
And what's an equation? It's a mathematical sentence with an equal sign in it. The expression on one side of the equal sign must have the same value as the expression on the other side.
Do you have enough frame?
Well, I've got 200 centimeters. Euclid said I need 160 centimeters, so I have 40 centimeters left.
Hey, look. This looks pretty expensive. What is it?
Oh, it is. This is very expensive, Kanwal. This is the frame that the president of the club, Ramon, picked out for his print Grandmother with Tropical Fruit.
Grandmother with tropical fruit. Oh. I don't see a picture of a grandmother here.
Yeah, I know. That's because he hasn't done it yet.
Oh.
But the frame is so expensive that he doesn't want me to waste any of it. So he's asked me to calculate how big a frame I can make using this standard length.
Now, what is the length of this piece?
This is 120 centimeters long. Oh, and Ramon said the picture is twice as tall as it is wide.
Good. That should be enough information for us to calculate.
Good. Well, let's get some of this information down. Euclid, can you write this down for us? Euclid has written something with an equal sign in it, so we could call it an equation.
But it also has a letter representing an unknown quantity in it, W. So we could also call it an algebraic equation. Let's look at it visually. The width is W. It is twice as tall as it is wide, so it is 2W. The other side is 2W, and the top is W. Let's write it as an algebraic equation. W plus 2W plus W plus 2W is equal to 120 centimeters. We collect the like terms, 1W plus 2W plus 1W plus 2W, which is 6W, is equal to 120. Now, in order to isolate the variable, I multiply the 6 by its reciprocal, 1/6. Remember that when you multiply a number by its reciprocal, the answer is always 1. In order to balance the equation, I multiply the right side by 1/6 also. So, W is equal to 120 divided by 6, which is equal to 20 centimeters. So the width is equal to 20 centimeters.
Great. So I can tell Ramon that the biggest frame I can make him is 20 centimeters wide and 2 times 20 or 40 centimeters tall without wasting a single ruby.
Certainly not. What's next up on your order book?
Oh, next I have a picture from my friend Geraldine, and it's sort of a moody piece called Forest Fantasy.
Forest Fantasy. I don't see any forest here.
That's right. Now listen, Geraldine is a very dedicated conservationist, so she doesn't want to waste any frame.
But that's just the problem we did.
Not quite. The shape of the pictures is different. This one's taller than Ramon's. In fact, the height is twice the width, plus 5 centimeters. Okay, Euclid, your turn.
W is our width. The height is 5 more than twice the width. So the height is 2W plus 5. This is also now 2w plus 5. Let's write an equation. W plus 2w plus 5 plus w plus 2w plus 5 is equal to 120 centimeters. Let's solve the equation. Collect the like terms. I add all the w's together, which gives me 6w, plus I add the two 5's together, which is 10, is equal to 120. So, now let's isolate the variable, and in order to do that, I subtract 10. Remember, whatever I subtract from one side of the equation, you must subtract from the other side as well. So I subtract 10, which gives me 6w is equal to 110. Now, we haven't totally isolated the variable. So now I'm going to get rid of the 6 by multiplying both sides by the reciprocal of 6, 1/6. This gives me w is equal to 110 divided by 6. I don't think this is going to be a whole number, so I'm going to use my calculator. I go 110 divided by 6. This is equal to 18.3 repeating centimeter. So my width, rounded off to one decimal place, is 18.3 centimeters. Now, to find the height, let's substitute the value of the width that we just got. So I've got 2 brackets, 18.3 repeating, plus 5. Let's do that. 18.3 times 2 plus 5 is equal to, rounded off to one decimal place, this is 41.7 centimeters. Remember your poster? Check your answer. Euclid, could you do that? Substitute the 18.3 repeating into the equation. So 119.9 repeating will be rounded off to 120. So the answer is correct.
And the dimension for Geraldine's frame are 18.3 centimeters by 41.7 centimeters. But Kanwal, that's not the only way to handle an equation, is it?
Oh, no, certainly not. There are different ways of approaching equations.
So what's the best way to begin solving an equation? Well, you should begin by simply inspecting the equation and using your common sense. Just because it has a letter in the expression doesn't mean it has to be difficult. Euclid, some simple examples, please.
When you see simple equations like these, you may find that the answer is obvious. So before you do anything else, just look at the equation. For example, you might look at this last equation and say, x over 2 equals 3. That means something divided by 2 is 3. What do I have to divide by 2 to get 3? It must be 6.
If you find that the answer doesn't jump out at you, then maybe you need to do some intelligent guesswork.
You mean it's okay to guess in mathematics?
Yes, it's okay to guess in mathematics. Sometimes that's the quickest way to an answer, especially if you think before you guess.
Let's look at an example. We don't know what x is, but we have to begin somewhere. So let's start with a guess of 1. If we substitute 1 for x in the expression, we get 5 times 1 is 5. 5 subtract 3 is 2, so the expression works out to 2. And that's too small. We need 12, not 2. So we try something higher. Maybe 5? This time we find the expression is equal to 22, which is too large. So we now know that the value of x that makes this equation true is between 1 and 5.
But look, Kanwal, our target 12 is halfway between our first two attempts. So maybe the value of x is halfway between 1 and 5.
Very good point. If we try 3, which is halfway between 1 and 5, we find that 5x minus 3 is 12, which is exactly the value we're looking for.
So sometimes intelligent guesswork is the best strategy. But whichever strategy you use, it's important to remember that the two sides of an equation are equal. And just to demonstrate this point, I'd like to show our viewers my new equation machine. Now, it's not a calculator, and it's not Euclid, it's this. A scale. When the mass on the two sides of the scale are equal, it balances. It's another way of showing what we have to do to solve an equation. Euclid, could you oblige us with an example? R plus 2 equals 7. Okay, so let's let this block represent our unknown, the R in the equation. R plus 2 equals 7. So, what would you do with that, Kanwal?
To isolate the R, I subtract 2 from each side. My equation is still balanced. R equals 5.
Great. Euclid, could you give us another equation? Okay, 2n plus 5 equals 11. Okay, Euclid, you balance this one.
Subtract 5 from each side and divide both sides by 2. N is equal to 3.
Of course, you're not always going to have a balance around when you need to figure out a problem. So the thing to remember is, whatever you do to one side of an equation has to be balanced by the same action on the other side. Now, Kanwal, do you think you can give us another example without using the balance?
Of course, Christine. I'm just getting warmed up. Euclid, pitch me another one. See, 8x plus 6 minus 2x is equal to negative 4x minus 10 minus 4. Now, 8x minus 2x, let's collect the like terms on one side, which is 6x plus 6. And on the right side, I have negative 4x minus 10 minus 4 is minus 14. Now, we want to isolate our variable, so let's get rid of the negative 4x and add its opposite to both sides, which is plus 4x. That gives me 10x plus 6 is equal to negative 14. Now, we continue to isolate the variable by adding the opposite of 6, which is negative 6 to both sides. Now, that gives me 10x is equal to negative 20. We've got one more step. To isolate the x, I multiply both sides by the reciprocal of 10, which is 1/10. And that gives me x is equal to negative 20 divided by 10, which is equal to negative 2. And now, Christine,
I'm right here, Kanwal.
oh, you're out in the field again. Are you ready to give us your report?
I sure am. You know, even people who think they don't like algebra use it every day without blinking an eye because they call it something else. They call it formulas. For example, when you exercise, you want to raise your heart rate, right? But there's a limit. You don't want to raise it too high. In fact, everyone has a red line, a maximum heart rate you should not exceed when you exercise. The maximum rate depends on your age, and you can find it by using this formula. 220 minus A equals maximum beats per minute. A stands for your age. What do you think? Looks a lot like an equation, doesn't it? And it is. A formula is a standardized equation that fits a particular real-life situation. People also use formulas to figure out interest on a loan, or to calculate the volume of wood in a tree, or to convert nautical miles to kilometers. And there are lots of other examples, too. So, if you know how to work with a formula, you've got a good start on solving any algebraic equation. Now I'm going to hit the showers. So it's back to you, Kanwal.
Thanks. Well, one thing that Christine's report showed is that formulas are designed to solve problems. And here at the Math Shop, we know that problem solving is a big problem for students. Let's take a look at one now. Euclid, our word problem, please. A mid-sized automobile can be equipped to run on natural gas for approximately $3,000. To encourage people to convert their cars, the government is willing to subsidize this cost to the tune of $1,250. Average fuel cost for standard gasoline engines in 1993 was 7.4 cents per kilometer. The cost for natural gas was 3.6 cents per kilometer. At these rates, how far would a car need to be driven before the extra cost of the natural gas conversion would be recovered? Thanks, Euclid. Well, let's solve this problem. My gas guzzler here costs 7.4 cents a kilometer. Converted to natural gas, my car would cost me 3.6 cents a kilometer. Ooh, what a savings! But I don't get that saving right away because there's a conversion cost of $3,000 and there's a subsidy of $1,250. Now, the question is, how far must I drive to begin making that savings, to reach that break-even point? Let's use a variable d to represent the distance in kilometers. Traveling in my gas guzzler will cost me 7.4 cents a kilometer. Now, let me convert that to dollars, so this will be decimal 0.74 times the distance d. And converted car in the natural gas will cost me decimal 0.36 times the distance d plus the $3,000 conversion cost minus the $1,250 subsidy. The question is, what is the break-even point? So that's my equation. Well, let's solve it. Let's do the subtraction first. 0.074d is equal to 0.036d plus 1,750. To isolate the variable, I subtract decimal 0.36 from each side. So I've got minus 0.036d on the right side and minus 0.036d on the left side, which gives me decimal 0.38d is equal to 1,750. Now, to isolate the d, let's divide both sides by decimal 0.38, which gives me d is equal to 46,052 kilometers. So I have to drive over 46,000 kilometers to make the conversion worth my while. That would take me about 2 years to drive, or maybe it's worth it.
Hi, Kanwal, I'm back.
Oh, just in time. I think we need to go back and revisit Ramon's frame.
You mean the one with his grandmother in it?
That's right.
I thought that we solved that.
We did. But supposing the question had been different. Suppose Ramon was a big spender and didn't care if he wasted a single ruby.
Oh, okay, I see where you're going. You mean, what if he'd asked, what different sizes of frame can I make from this piece when the length is twice the width? Not the biggest, but just what different size frame.
That's it.
Right, okay, now we know that the largest width was 20 centimeters, but we could build smaller frames. Euclid, could you give me some examples, please? We could write the same thing in mathematical language like this, which says W is less than or equal to 20. And just like that, we've entered the world of inequalities.
In other words, you may sometimes get a range of solutions to a problem, and then the equal sign goes out of the window, and we have to use these signs.
And they mean less than, greater than, less than or equal to, and greater than or equal to.
Generally speaking, the rules that apply to equations also apply to inequalities, with one exception, but we'll get to that exception in a minute. The further to the right on the number line, the greater the number is. 3 is less than 5. If I add 2 to both sides of the inequality, you see the inequality still holds. 5 is less than 7. Let's try another operation. If I multiply both sides by positive 2, see the inequality still holds. 6 is less than 10. Now the exception is when you multiply or divide by a negative number. Again, let's start with 3 is less than 5. Multiply both sides by negative 2. Our inequality doesn't hold any longer. Notice negative 6 is actually greater than negative 10. So multiplication or division by a negative number requires a reversal of the inequality sign. So Christine, do you think we have covered inequalities?
Like a blanket, Kanwal. But listen, while Euclid has these number lines up, why don't we discuss absolute values?
Good idea. Okay, the absolute value of any number is always positive. Absolute value of 5 equals 5. Absolute value of negative 5 equals 5. The absolute value of any number represents the distance from 0 on the number line without considering direction. Therefore, the solution to a variable within absolute value bars can be either positive or negative. In the case of absolute value of h equals 13, both h equals 13 and h equals negative 13 are true.
Kanwal, that is absolutely clear. Okay, now we've just got time for our calculator test!
Wow, that's impressive.
Thank you very much. I've been working on that one for about a week.
Very nice, but please, no more special effects.
Well, maybe just one more.
Whew, all right, the calculator tip. This show, we've been working on algebraic equations. If you use your calculator to work backwards through an equation, reversing the operations, you'll often be able to solve it. Here's what I mean. X minus 13 is equal to 42. So I start with 42, opposite operation, plus 13 is equal to 55. So my answer is 55. Let's do another example. 3y plus 5 is equal to 17. Now I start with 17, opposite, minus 5. Instead of multiplying, I divide by 3, which is equal to 4. So y is equal to 4. Let's do one more example. 2k divided by 3 minus 10 is equal to 40. Now this time, I'm going to start with 40, add 10, equals. Now I'm going to divide by 2 and multiply by 3. And my answer, k is equal to 75. And it looks like that's about all the time we have today. So what are you doing, Christine?
Whoa! It worked! Hey, Kanwal, how do you like that? It's your own personal special effect. I was going to get you lasers and flashpots, but Metallica's in town. Kanwal?
Can you hear me?
Hey, how do you like?
Christine, get me out of here.
Well, it seems that we are out of time on Math Shop today. Thanks for joining us, and we'll see you next time. Kanwal. Hang in, relax. Hi, is this Houdini software? Mr. Dini, please. Right. Oh, hello, sir. Right, I'm the person who came in and got the handbook from you. Well, it seems, just in a monitor. Right, a monitor. It's not my fault. I took a bit of light. Kanwal? Sorry, I couldn't hear you. What? Right. Hey, do you guys have videos? Oh, yeah. What about Eraserhead or anything?